Alright guys, so this is our first Flip the Classroom lesson of Chapter 2. This lesson is going to be about finding the real zeros of polynomial functions. We're going to break this up into 3 videos. The first video is going to be on polynomial long division. The second video is going to be on synthetic division, and the third video will cover the rational root theorem. Alright, so when we talk about polynomial long division, we are mainly concerned with lead terms of the dividend and the divisor. So right here, for our example, we have f of x equals x cubed plus 2x squared minus 9x minus 15, and that's being divided by our d of x, which is x squared minus 10. Right here, the thing that we're dividing is the dividend, and the thing that we're dividing by is the divisor. So right here, when we set up polynomial long division, basically we are going to set it up just like regular long division. One thing that we want to make sure of, though, is that all terms are represented in the dividend and the divisor. So right here we can see that our divisor, x squared minus 10, is missing the linear term. So when we set up our polynomial long division, we're going to say this is x squared and then plus a 0x minus 10. So that 0x is really just 0, but it's a 0 term that's going to hold the place of the linear term. So when we do our polynomial long division, our like terms will match up. So right here we are dividing our x cubed plus 2x squared minus 9x minus 15. And when we say that we are mainly concerned with the lead terms of the dividend and the divisor, really what we're talking about is the process of polynomial long division, which is going to be canceling out the lead term of the dividend in each step of the polynomial long division by recreating that term with the lead term of the divisor, right? So what we're basically going to be saying is, what do we need to multiply our x squared by in order to get x cubed here? And of course that's going to be x, right? We multiply x squared and our x, and we get x cubed. Whatever we multiply the first term of our divisor by, we're going to multiply the next two terms by. And right here we will get plus 0x squared, and then right here minus 10x. Now, at this point, what we're going to do to cancel out the lead term of our dividend is distribute a negative through this expression right here, which is going to give us negative x cubed minus 0x squared and plus 10x. What we'll see right here is that when we combine like terms, we get our lead term of the dividend to cancel out, and we're going to end up with 2x squared minus 9, whoops, not 9, but minus, really plus x, and then right here minus 15 when we drop down our next term. Now in the second step, we're basically going to do the exact same thing, right? We're going to try to cancel out the lead term of the dividend by figuring out what we need to multiply the lead term of the divisor by in order to get that lead term of the dividend, and then we are going to distribute a negative through and get additive inverses. So what do we need to multiply x squared by in order to get 2x squared? That's going to be plus 2. So right here we distribute that 2 through our divisor, and we get 2x squared, and then right here we're going to get a plus 0x, and then right here we're going to get a minus 20 for the multiplication of 2 and then negative 10. Now when we distribute that negative through, we're going to get minus 2x squared minus 0x and plus 20, and the lead terms cancel out, and we are left with x plus 5. Now since there's nothing we can multiply our x squared by in order to get just x, we would say that this x plus 5 is our remainder, and what we have right here with our x plus 2 is our quotient, right? So there are a couple ways we can represent the polynomial long division we've just done. We can represent it in polynomial form, which is going to basically recreate the polynomial f of x by representing it as a multiplication of the divisor, x squared minus 10, times the quotient, x plus 2, and then plus the remainder, which is x plus 5. So right here what we're saying is if we multiplied our divisor and our quotient and added our remainder, we would get back to our original polynomial f of x. The second form that we can represent our polynomial long division with is fraction form, and this is basically just a representation of the division that we've just did. F of x divided by d of x gives us the quotient, x plus 2, and then right here we have our remainder, right, which we cannot put x squared minus 10x into, so right here that remainder, x plus 5, is still being divided by x squared, and then right here, minus 10. Right here, another way for us to represent the polynomial long division we've just done here is by taking our x cubed plus 2x squared minus 9x minus 15 and dividing it by x squared minus 10. This is actually what we're seeing right here with our f of x divided by d of x. And it's another way for us to look at the polynomial long division we're actually doing right here, right? We're dividing the cubic right here, x cubed plus 2x squared minus 9x minus 15 by our x squared minus 10, and that's giving us the quotient of x plus 2 and then plus the remainder still being divided by the divisor. So right here, why don't you guys go ahead and give this one a shot. We'll pause the video and then do it together in a little bit. Okay, so we can see that we're not missing any terms from our f of x, our dividend, and we're not missing any terms from our divisor, our d of x. So we can go ahead and just set up our polynomial long division and go to work. So again, we're concerned with lead terms in the dividend and the divisor, and what we're trying to do is cancel out the lead term and the dividend in each step of our polynomial long division. So first step is to recreate that term. So we're going to say, what do we need to multiply x squared by in order to get x to the fourth? And that's going to be x squared. So right here we will multiply x squared through our divisor and get x to the fourth. And then right here plus 2x cubed, and then right here we're going to see a minus 3x squared. Now if we distribute that negative through to get additive inverses with our lead terms, we're going to get a negative 2x cubed and a plus 3x squared. Combining like terms, we see our lead terms cancel out. This is going to be a minus 6x cubed, and right here we are going to end up with a minus 3x squared. And then we can drop down our next term, which is a plus 36x. Okay, next term to cancel out is negative 6x cubed. So we're going to say, what do we need to multiply x squared by in order to get negative 6x cubed? And that's going to be a minus 6x. So we distribute that negative 6x through, and we get negative 6x cubed. And then we're going to get a minus 12x squared. And next, when we multiply negative 6x by a negative 3, we get a plus 18x. Now again, we're going to distribute the negative through to give us additive inverses. So that's going to be a plus 6x cubed, plus 12x, and a minus 18x. Lead terms cancel out, just like we planned. And right here we get 9x squared, and this is going to be plus 18x. And then we drop down our last term, which is a minus 27. And right here, we're looking to cancel out that 9x squared. So right here, what do we need to multiply x squared by in order to get 9x squared? That is going to be 9, so we'd say plus 9. Then we multiply through by that 9, and we get 9x squared. And then this is going to be 9 times 2x is going to give us plus 18x. And when we multiply 9 and our negative 3, we get minus 27. When we distribute a negative through, we get our additive inverses, and right here, what we're seeing is the 9x squared is going to cancel out with a negative 9x squared. Combining linear terms, we see that we again have additive inverses, and finally right here with our constants, we have a negative 27 and a positive 27, so that cancels out those as well, and we have a remainder of 0. What does this mean? This means that our x squared plus 2x minus 3 excuse me, guys, is a factor of our f of x, right? So basically this quadratic is a multiplication of two linear factors that are also linear factors of f of x. And what we're left with is the quadratic right here. So writing this in polynomial form, we would get f of x equals the divisor, x squared plus 2x minus 3 times the quotient x squared minus 6x plus 9. And right here, this is polynomial form to sort of represent that. So right here, that's polynomial form, poly form, we'll call it. And when we represent this in fraction form, what we're seeing, there's not much room here, is there? Well, stand again. What we're seeing in fraction form here is our f of x divided by our d of x, which is going to give us the quotient, rather, x squared minus 6x plus 9, and there is no remainder. So basically, when we divide f of x by d of x, we get just our x squared minus 6x plus 9, which is basically the multiplication of the other two linear factors that are making up our fourth degree polynomial. All right, so why don't you guys stop this video and move on to the next one.